So it's really a privilege for me to be here, especially when it's almost, the weather is just about exactly like it is back in Michigan. And so before I'm going to punch this little button here, some of you might be wondering what cats have to do with statistics, and that's what we're going to talk about. And so here's some statistical information that comes from Ann Landers, where kids aren't worth it. Comes from when cats fall off buildings, the chance of survival goes up the taller the building. And of course we all know about kindergarten scores and what they do, how college is successful if you're in algebra. Algebra 2 is a really indication of success, and kids who have taken Algebra 2 have all these more opportunities that are going to do better things. So we really have a lot of things, but people are making decisions based on data, and they're forgetting a really important piece of this. Data is my stuff. The piece is, how was the study designed and where were the data gathered? And they make a lot of educational decisions on data. Like, my daughter did not succeed in that book. Get rid of it. My daughter didn't succeed with that teacher. I need a new teacher. This is not how I learned in Singapore or Japan or whatever. They have companies who make money, lots of money, not math for them, by selling data books about how you can master all this data stuff about teachers and classrooms, and you will improve your school. We're completely data driven. There's walls, data walls. You guys have data walls? What for? The message is that data is useful, but people ignore the variability. They ignore where it's collected and how it's being used. Statistics is not about individuals. It's not about you as an individual teacher. It's about trends. It's not about me and how much money I have in my pocket. It's about the trend about how much money we all have. It's about what's going on as we look at test scores over grade levels for groups of kids. And we're looking at trends about understanding the variability that's going on. And so when we think about this, we have to say, okay, it's not about my cholesterol level when I take a new drug. It's about what's going on overall. What can I say about this drug? What's the pattern? What's going on? So the kinds of things that we're thinking about with data that are important are in the Common Core State Standards, if we take time to think about how this might play out in our classrooms. Big, good ideas are there that we should become familiar with as we move through. Like, not everything is normal, especially our kids. I've heard enough about some of these kids to know that you guys all have really, really typical kids who aren't normal, right? So the idea here is that randomness is central. Randomness has a pattern to the way things behave that's a key part of what we ought to let kids experience when they're learning the statistics and the ideas. And that variability is kind of controlled by randomness. So again, we can learn by looking at things and simulating things. Do things happen by chance, or was there something else going on? We don't do enough of thinking about that when we make these decisions on schools. So you guys have a lot of people in your state, so this might not be, but this is in Wisconsin. A difference of 10 points on the achievement test can mean principals and teachers are fired. But the school has only got 80 kids in it. So that doesn't work. Another thing we have to think about is statistics is not mathematics. Statisticians do not do exponential regressions. We talked about that in my talk this afternoon. So there's some principles that we should be thinking about when we're teaching statistics. Important principles. Nothing is certain. The second one is my favorite. If you don't know where the data came from and what was asked, you don't know much and you can't say much. You have to know what typical behavior is before you can tell when something is not typical. Correlation is not very important. R squared is. It's not about making the plot. It's about thinking about what the plot means. So some recommendations, and when I actually put these recommendations down and was looking at them, I noticed that these recommendations could be for teaching mathematics as well as for teaching statistics. The deal is we want to be data rich, not information poor. and we want to make sensible use of the data, and we want our administrators and school boards to make sensible use of the data as well. Thank you.